Welcome, viewers, once again to our online mathematics lessons. My name is Mr. Onyango. We're still on with the topic logarithmic equations. Although we are coming to the tail end of the topic, we have discussed how to solve logarithmic equations with the same base. And today I would like us to look at a special type of logarithmic equations with different bases. For example, log of x to the 3 minus log of x to the 9 equals to 1. You can see the bases are different, and the approach to solving this is not like what we've discussed in the past. Before we discuss this, I would like to remind you of two concepts. One of the concepts is the concept of changing the base of a logarithmic expression. For example, if we have log a to base b, log a to base b, we have log a to base b, and we'd like to change this expression to base c. We write it as log of a to base c over log of b to base c. For example, if you have log of 5 to base 2 and you'd like to change this to base 5, we can apply this formula. And so we shall have log of 5 to the new base 5, and then log of 2 to the new base. But you remember that log of 5 to base 5 is simply 1, and then in the denominator we shall have log of 2 to base 5, and that is to say log of 5 to base 2 is the same as 1 over log of 2 to base 5, and our new expression is now 2 base 5. Now, the other concept is the concept of changing an exponential equation to a logarithmic form, or the vice versa. Suppose we have 8 equals to 2 over 3. This is an exponential equation, an exponential form. In this, 8 is the number, 2 is the base, and 3 is the power or the exponent. We also call it the logarithm. So this means that the power of 8 to base 2 is 3, or simply the logarithm of 8 to base 2 is 3. That is the logarithm of 8 to base 2 is simply 3. The rule is that if I have a to the power n equals to b, this is the same as log of b to base a equals to n. And this again is a very important rule. For example, if you are given log of x to base 2 equals to 1, this is a logarithmic form. You can change it to exponential form, where this is the power, this is the number, and this is the base. And so we shall have that x equals to 2 to the power 1. Now, with those two concepts, we are ready to take on this equation. And so that equation is log x to base 3 subtract log x to base 9 equals to 1. This is a logarithmic equation where the bases are not uniform. We have base 3 here and we have base 9. We decided to change this expression to base 9, or we change this expression to base 3. I choose to change this expression to base 3, and so we have log x to base 9 will be written as log x to base 3 over log 9 to base 3, we shall proceed and have log x to base 3 over log. We can write this as 3 power 2, but then the base is 3, and go further and write it as log of x to base 3 over 2 log 3 to base 3. And you realize that we have log 3 to base 3, which is 1, and so our expression now becomes log x to base 3 over 2. That is to say, where we have log x to base 9, we shall replace it with log x to base 3 over 2. So our equation is transformed to be log x to base 3 subtract log x to base 3 over 2 equals to 1. I hope we are together. And with this, we can introduce a new variable by letting log x to base 3 to be a new variable y, and so we shall have y subtract y over 2 equals to 1. We can multiply through by 2 so that we shall have 2y minus y equals to 2, and therefore our y is simply 2. So the value of y is 2. We can bring it back here so that if y is 2, it means log x with 3 equals to 2. This is logarithmic form, and we can change it to exponential form. Log this x equals 3 power 2, and therefore our x equals to 9. I would like you to attempt the following exercise. So we have number 1, I look to solve x is 2. Okay, and number 2, we have log x is 3 minus log 9 base x equals to 1. And the third one is log x is 4 plus log x is 2 equals to 6. You can try these 3 problems by way of practicing, and in our next lesson we will do this together, where I'll give you an opportunity to check your work against my work to see whether you did it correctly. I hope you enjoyed the lesson. Till next time, thank you very much. Welcome back, viewers. We're still continuing with our online mathematics lesson series. My name is Onyango. In the previous lesson, we discussed how to solve logarithmic equations with different bases, and at the end of the lesson, I left an exercise which I hope you have tried. And now I would like us to go through the first question of the exercise. This was the first question of the exercise, where we had log x to base 2 subtract log 8 to base x equals to 4. You realize that the bases are different. We have base 2 here and we have base x. Now, you either decide to change base 2 to move to base x, or you move from base x to base 2. I have decided to move from base x to base 2, and log 8 to base x is the same as log 8 base 2 divided by log x base 2, which we simplify the numerator as log of 2 power 3 because 8 can be written as 2 power 3, and this becomes 3 log 2 base 2 all over log x base 2. Now, log 2 base 2 is simply 1, and our expression simplifies to 3 over log x base 2. So, where we have log 8 base x, we shall substitute 3 over log x base 2, and this is our new equation. At this stage, I introduce a dummy variable, y, so let log x base 2 be y. So where there is log x base 2, I replace with y, and I have y, subtract 3 over y equals to 4, which comes to y squared minus 3 equals to 4y, having multiplied through by y. And if I rearrange, I have y squared minus 4y minus 3 equals 0. This is a quadratic equation. Now, this quadratic equation cannot be solved by factorization method, and so we solve it using formula method, which I believe you are conversant with. And so we substitute the value of a, b, and c into the formula, and here we are. We come to 4 plus or minus root 28, and we have two values of y. Y is 4.646 or negative 0.6458 to four significant figures. This is the value of the dummy variable. Now we take it back to this point. Where there is y, we replace with the value of y. And so when y is 4.646, log x base 2 becomes that. This is a logarithmic form. We move from logarithmic form to exponential form, and so our x is equals to 2 power 4.646, which gives us the value of x as 25.04. Next, when y is negative 0.46458, we have log x base 2 equals to negative 0.6458. This is a logarithmic form, and we convert it to exponential form, and we have x equals to 2 power negative 0.6458, and that simplifies to x equals to 0.6391. And so our two values of x are 25.04 and 0.6391. I hope you got it right. Now, let us look at the second question of the exercise. We have log x base 3 subtract log 9 base x equals to 1. Once again, this is an equation with different bases. We either move from base 3 to base x or from base x to base 3. I have decided to move from base x to base 3. And so I am writing log 9 to base x as log 9 base 3 divided by log x base 3. Log 9 base 3, 9 can be written as 3 power 2. So we have log of 3 power 2 to base 3 over log x to base 3. These two can come down so that we have 2 log 3 base 3 all over log x base 3. Now, I hope you still remember that log 3 to base 3 is the same as 1. So it is 2 times 1, which is 2 all over log x to base 3. Therefore, where we have log 9 to base x, we shall replace it with 2 over log x to base 3. And this equation now transforms to log x base 3 subtract 2 over log x base 3 equals to 1. I introduce a dummy variable t by letting log x base 3 to be t. Where there is log x base 3, I put t, and now I have t subtract 2 over t equals to 1. Multiply through by t, I have t squared subtract 2 equals to t. Rearrange, we have t squared subtract t subtract 2 equals to 0. Once again, this is a quadratic equation in t, and we can solve this using factor method by breaking the product. The product of a times c is negative 2. We break it as negative 2 and 1, And so we shall have t squared subtract 2t plus t minus 2 equals 0. We factorize by grouping t into t minus 2 plus 1 into t minus 2 equals 0, and the factorization of the left hand side turns out to be t subtract 2 into t plus 1 equals 0. From this, our t is 2 or t is negative 1. Now, we take t back to this relation. Log x is 3 equals to t. Now that we know the values of t, when t is 2, we have log x is 3 equals to 2. This is a logarithmic form. We transform it to exponential form, where we now have x equals to 3 power 2. That is, 3 is the base and 2 is the power. So x is 3 power 2, and that gives us x is 9. The same thing again when t is negative 1. We have log x base 3 equals to negative 1. We move from the logarithmic form to exponential form of x equals to 3 power negative 1, and our x equals to 1 over 3. I hope you remember the laws of indices, the negative laws of indices. Therefore, x equals to 9, and x is a 9. I hope you got question 2 right. Let us finally look at question 3, the final one. This is log x base 4 plus log x base 2 equals to 6. The bases are not the same. We either move from base 4 to base 2 or from base 2 to base 4. I have decided to move from base 4 to base 2 so that I rewrite log x base 4 as log x base 2 divided by log 4 base 2. This will be log x base 2 divided by log 2 power 2 base 2, because 4 can be written as 2 power 2, and this will give me log x base 2 divided by 2 log 2 base 2. Log 2 base 2 is 1, so this becomes log x base 2 all over 2. Where we have log x base 4, we shall replace it with log x base 2 all over 2. Now, so we now have log x base 2 over 2, because where there is log x base 4, I have brought in this plus log x base 2 equals to 6. You can now see the bases are the same. I introduced the variable m. Log x base 2 is m, so that where we have log x base 2, I replace it with m, and I have m over 2 plus m equals to 6. We multiply through by 2. Multiply through by 2. We have 12 here. That is right. We have 12, and so m is 4. So when m is 4, we shall have log x base 2 is 4, which is a logarithmic expression. I bring it to exponential form, which is 2 power 4, and therefore my x is 16. Thank you very much. To this end, we have completed the topic logarithmic equations, and I hope you should be able to tackle any question on logarithmic equation.